SRT 2.2. I'll try and go pretty quickly for this task. Sorry, not SRT 2.2. Task 2.2. That's why. Anyway, we've got the algorithmic complexities here. Let's start with introspective sort, which was really interesting when I was researching it. So I guess I won't read it out, obviously, because that's pointless. But I'll try and reword it a bit to explain it verbally. So what's special about it? This sorting method is it's smart because it starts with quicksort, which is fast for most of the cases. But then if it notices that the recursion is going too deep, which would lead to a bad case for the quicksort, it'll actually switch to heap sort, which is really interesting. So it's a really good dynamic way. And then if the subarray is really small, it'll just use insertion sort as well, which is great for tiny chunks of data. So it combines all three of the sorting methods, and then it uses it at the right times, which is fantastic. It is unstable though. So if two items were equal, the array wouldn't really be preserved after sorting. So you can't really rely on the order staying the same when the values are equal. The time complexity. So the best case is big omega. The average case is big theta, and the worst case is big O. The cool thing is though, when it stays like fast by switching to heap sort, avoiding quick sorts like it avoids quick sorts like bad big O, the linear performance, which is good. So time methods. So before I start, I probably should explain what does O bracket 1 mean and what does ON mean. So we've got so O1 pretty much means it's constant time. So the operation will take the same amount of time no matter how much data there is. And then the linear time is ON. So ON is linear time. So it'll take like it'll grow with the size of the array, if that makes sense, or of the input, which is n. So it's O1 constant, take the same time, and then ON is different. So let's start. It's the first one, constant. It'll return the internal counter. The add, this one's amortized. That means the average time per operation over a sequence, excluding like what's it called? Is it not an uncontrolled variable? So you got the upper bound and lower bound outside, an outlier. Sorry, I couldn't think of the word. But yeah, it'll include the rare ones. Yeah. But we can go back to it. So, so that's add. So usually, it's usually not linear, so it's usually constant. But if the array is full, it resizes and copies everything, which then takes on the linear, because then it's got to go through all of them again and then add. Insert, obviously going to scan through all of them because it needs to insert the value where it is. So that could take years, or it could take a second. So it's linear, depends where the item is. Clear literally just resets the count to 0, so it's constant. Contains, it checks the item to see if it matches, so it's got to scan through all of them, which means it is linear. Remove at, same thing, needs to shift all of the items after it, which could be ever, but it also has to find the item as well. So definitely linear. Remove, same thing, linear. Finds the item, so that's gonna go through them all. Index of. Actually, I should say for remove at doesn't actually scan. That's the remove, but the remove at actually takes that, but then it has to shift anyway, so they're both linear. The index of, you may need to scan the whole list before you find the index, obviously, because it's going to go through them all and then find, okay, the index of da da da. But it's going to scan the whole thing for da da da. So, and then the capacity just gives you a length of the array, so that's simply constant. And then does it match the .NET? And it does. It uses the same approach, dynamic arrays with resizing and shifting logic. And also the time complexities are the same. So, true or false questions now. So the first one, A, was true, because, n cubed, constant, or linear, it grows way faster than log n, because n, it gets big. Simply true. B, I think B was if it was already sorted, single pass confirms that in bubble sort, and it was true, because if bubble sort has like an early exit flag and nothing is swapped in a pass, we already know it's sorted. C was true. Apparently one of these were wrong as well, so I could be saying something wrong, but anyway, I would love to know what I did get wrong, because I think I had one more wrong. Might have been in 4 though, but anyway. 3C, sorry, yeah. So I think that question was the reversely sorted array causes a max shift in insertion sort. And I thought that was also true, because the insertion sort has to move every item forward or to the right every time. Every time is the worst case, but it is the worst case, right? Yeah. D was selection sort is in place, and that's true. It doesn't need another array. It just swaps the item in the same list. E, insertion sort worst case space complexity of. I've got the PDF file just explaining the questions here, just so I can read it. But that is constant, and that was true because it uses a constant extra space and only variables and no extra arrays. So yeah, it's just constant. That was worst case. 2 plus 2 equals constant, because any fixed number, it means it's constant. So, sorry, any fixed number of steps, like it is constant time. So, yeah. So n to the power of 3 plus 10 to the power of 6 equals big O cubed, or linear cubed. And then I said it was true, I think, because the big O, it drops the smaller term and constants. Is that not? I'm pretty sure that's how it works. So, yeah. 3H was false. It said n log n equals big O n, because n log n, it grows faster than n, so it's not. It's not big O n. It would be O, like big O n log n. Then 3I. I wish I could draw it out. Actually, it'd be so easy to explain. Anyway, okay, going. Sorry, 3I. So that was log n equals O n, and that was true because log n grows slower than n, to the power of whatever. So yeah, that's what little o means. This was an interesting one. 3J log n plus 2 to the power of 100 equals big theta log n. So the constant values don't actually matter when it's big theta, because we only care about the term that it grows. So it is true. It's equal. Yeah. And 3K, n log n equals big. Oh wait, did I say that wrong? No, this is big omega n. Yeah. So n log n grows at least as fast as n, and that's true. So yeah. And then the last three I think were false. Yeah, here we go. So n plus 2n equals big O n linear. False, because the 2 to the power of n dominates n a lot, and the growth is it's exponential, not linear. So yeah, so that means it's yeah. So it'd be big O bracket 2n. So yeah. 3m 100 divided by n log n grows faster than n was the question, and it shrinks as n grows, does it not? So it definitely doesn't grow faster, but yeah, as n grows, 100 divided by n log n will be shrinking. And then factorial n, big O n, grows faster than any polynomial. Yeah, so it was false. Not equal. All right. Lastly, sorry, this is taking a while, but the runtime analysis for the code snippets. So the best case for the first flag was only their outer loop runs big O linear, and the worst case, if the flag is if it's true, the nested loop it'll run what will that run? That runs n to the bracket n minus 1 divided by 2. So O times, big O to the bracket of n squared. Yeah. So I guess that answers that. This is hard because it's so much talking about big O and everything. I hope it's not confusing. Anyway, so the second one, the first loop in O always runs, n amount of time. So if no random values are less than 0.01, the second loop doesn't run 0n. But the worst case is if all values are greater than 0.01, the second loop will run n amount of times. So big O n squared is what it'll be. And then the average case, the expected case, only 1% of the time we can expect count to be, equal to, or like equalish to, 0.1 n. So in that case, big O bracket n, is that what I put here? Yeah, 0.01 n2 equals big O n linear equal to 4.3. This is a bubble sort. This was a bubble sort pattern because there's no early exit flag, so it always runs the full loops. So we'll do the outer loop n amount of times, and the inner loop n minus 1 and n minus 2 times. So the total will be n loops, brackets, because it's timesing the amount of times n minus 1, and then we'll divide it by 2 comparisons. So the best and this one, the best and the worst case would be big O n for this one, I'm pretty sure, because I feel like this is the one I got wrong. But that in my head, because there was no early exit flags, there's nothing on there stopping a loop. But I guess there isn't for any other ones. But yeah. But if the early exit was added, the best case would be big O n, or like linear, for a sorted list if there was an exit added. So yeah. And I also wrote a summary table here just to wrap my head around it a bit more. So sweet, appreciate that. Thank you. Hopefully that didn't take too long. See you next time.